Okay, so this video is for day 16. It is actually in the second part, so 4.2 continued. From the CEMC work, question 5. Find two non-zero vectors that are orthogonal to, part A says 6, negative 5, and part B says 2, 1, negative 3. So we know that two vectors are orthogonal if their dot product is equal to 0. So since there's so many solutions for this, we're going to do it in general terms. So for A, I know that 6, negative 5 dot some vector, I'll just call it xy, must equal 0. So if I'm doing this dot product, I get 6 times x plus negative 5 times y, so minus 5y equals 0. And then I have a couple of ways that I could write this. I could isolate x or I could isolate y. I'm just going to isolate, there we go. I'm going to isolate my y, so I'll divide each by 5, and I get that y is equal to 6 over 5x. Now what this means is that I have this point, x 6 over 5x, and I could pick any value for x that I want. Let's just say 1, and then I would plug that in to figure out my y. So the point 1, comma 6 over 5 would be orthogonal to 6, negative 5. I'm going to do the exact same thing, and I will pick 2. And so if I plug that in for x, I get 12 over 5. So that vector is also orthogonal to 6, negative 5. You could do that with any x value that you want. I'm going to do the exact same thing for part B. This time we're in 3 space, but nothing really changes. I know that if the dot product is equal to 0, then the two vectors are orthogonal. I should tell you that I should be using square brackets this whole time, and I'm really sorry. I'm quickly trying to do this before I have to go for my duty. So if I do this dot product, I get 2x plus 1y minus 3z equals 0. This time I'm going to isolate for y just because the coefficient is 1. So I'm going to get y is equal to 3z minus 2x. So I have this point x. I have my y being 3z minus 2x, and then I'm going to have the point z. So this time when I'm creating any two vectors, I get to pick anything that I want for x and z. As long as they're not 0, because the question said non-zero vectors, I'll just pick 1 and 1. And then when I plug that in for the z and the x right here, 3 times 1 is 3, minus 2 times 1 is also 1. So this vector is orthogonal to the 2, 1, negative 3. I'm going to do it again. Maybe this time I'll pick 1 and 2. Again, it doesn't matter what I'm picking for my x and my z. So 3 times z, so 3 times 2 is 6, minus 2 times 1 is 4. So here's another answer. And you could do this as many times as you want, I guess.